Hello, in this Excel tutorial video for Chem 1B, we'll be looking at the next step in the data workup for experiment 7. Last time we standardized the sodium hydroxide calculation, we got an average and a standard deviation. This time we're going to move on and tackle the next set of data, which was the standardization titrations for hydrochloric acid. Okay, the data that I've collected this time is a volume of hydrochloric acid that was added to the Erlenmeyer. Then we added indicator and we titrated with the hydroxide. We know the concentration of hydroxide and we're trying to calculate the concentration of hydrochloric acid. Again, you've done these calculations as part of experiment 3 and you need to be familiar with how to do them by hand, but we're going to go ahead and do them using Excel to get some practice in those calculations. First, I'm going to calculate a volume of the acid that was used, a total volume, and a volume of the base. The volume of acid is equal to, and when we're typing equations into Excel, we use that equal sign, the final volume minus the initial volume. I want relative cell references here so that I can copy them across. The volume of base, likewise, is the final minus the initial. Now that I've calculated those volumes, because I know the exact concentration of the base, we did that last time, I can calculate the moles of sodium hydroxide. Need to make this column a little wider. The moles of sodium hydroxide is going to be equal to the volume of sodium hydroxide times the concentration of sodium hydroxide, and I'm going to use this average concentration, not the individual titration concentrations there. Because that volume is in milliliters, I need to divide by 1,000 to get my units to cancel properly, and that gives myself about 2.3 millimoles of sodium hydroxide. Because sodium hydroxide and hydrochloric acid have a 1-to-1 stoichiometric ratio in the balanced chemical reaction, I can calculate the moles of HCl that are consumed in this titration as exactly a 1-to-1 ratio, so it's equal to this number of moles. And finally, my concentration of HCl then is simply those moles divided by the volume of acid that was put into that flask at the start. Now, to deal with the units again, I'm going to multiply by 1,000, and that gives me a concentration of 0.11, which our target concentration was 0.1 molar, so that's about right. Now, last time I copied across each time. This time I've done one whole set of calculations. I can select that whole column, grab the handle at the bottom right, and drag that across here. Now, I ran into problems because this cell referencing the concentration moved. So there was a mistake in my equation there, and I need to go to that moles, and I want to take that C15 reference there, and I want to make that an absolute cell reference. So I put the cursor in the middle of that and hit F4, and it will toggle those dollar signs in. I could also type them in by hand. And then I take this and drag it across, and now things are calculating properly. Just like before, I want to calculate an average and a standard deviation. And that average is equal to, the function name is average, open parentheses, drag over the numbers, close parentheses, and the standard deviation likewise. And that standardized our hydrochloric acid. In the next video, we'll move on and we'll do the standardization of our weak acid solution and the weak base solution, and those are the final two steps before we can get to titration curves.